All right, so here we're asked to find the inverse. So let's kind of go through these steps together. What's the first step for finding an inverse? Can somebody tell me? First of all, you guys need to take your earbuds out, take your hoodies off, and put your cell phones away. And we'll try this again. What's the first step? Somebody was going to say it, yes? Yeah, wherever there is f of x, we're going to plug in a y. So we start with f of x is equal to negative x squared. I should also point out that they give us a domain restriction. Okay. So now what does that mean? Well, that means that when I get to my inverse, f inverse has a range that's the same as this. So the range would be less than or equal to 0 for f inverse. So we're going to do a bunch of math, and when we go to graph it in Desmos, we have to, because the domain is restricted in the original function, then the range is restricted in the inverse. So keep that in mind, right? All right, so replace f of x with y. What's step 2? Solve for x. So that means when we're done, we should have x equals some stuff. Oops, I misspelled the word stuff. That's some weird kind of shorthand there. All right. So, believe it or not, this is negative 1, so I'm going to divide both sides by negative 1. I get negative y is equal to x squared. Now this is an interesting thing. I'm going to have to divide, or not divide, undo the square by doing the square root. Whatever I do on one side, I have to do to the other. Notice that, remember, Mr. Adams said that we're going to have this range thing, and we said that y would have to be restricted to less than or equal to 0. What does that make this? That means we're going to have to plug in a negative y, and when we have a negative number here and we multiply it by a negative, that gives us a positive. Otherwise, we wouldn't be able to take the square root of it, right? Anyways, let's keep plugging along and see what we get. So when I take the square root of both sides, I get x. And we should probably do the plus or minus thing over here. And we will take a look-see when we're done. Okay? 3. Oh, well, I should, I kind of misspoke. When we talk about the range, we're probably going to ignore this positive solution. But this negative y thing will become an issue after step number 3, which is what, guys? What's step number 3? Yeah, we're going to swap the x and y's. So on the next line, I'm going to say plus or minus, probably going to ignore the plus part. Square root of negative x is equal to y. So I'm just going to rewrite this up here like this. What's step 4? Anybody know step 4? Now, if you haven't memorized this off the top of your head, just look at your notes. Yeah. Yeah, so wherever there's a y, we're going to plug in the f inverse notation, right? And I'm going to change the color for this because we got to talk about a few things. So we've got f inverse of x is equal to plus or minus the square root of negative x. So now, because I said that the domain on the original function was restricted, our range will be restricted. So that means we're only going to focus on the negative, because whatever this is, when it comes out of this square root thing, we're going to have to only consider the negative solutions because the range has to be negative. But we cannot take the square root of a negative number, so now we have a domain restriction just by the nature of the inverse function. So because we're multiplying by a negative, then our domain here also has to be negative. Now it could be 0 because you can take the square root of 0, you know. But so there's also an additional domain restriction. This is something we're going to have to do when we go to graph this. So to double check our work, the easiest thing to do is graph it in Desmos. So what I'm going to do, I'm going to fire up my Desmos. And I'm going to say f of x is equal to negative x squared. But I need to put a restriction on it. We said that x has to be less than or equal to 0. Okay? So on Desmos, this is, and by the way, Desmos is what you use on the SAT. Remember, that's embedded, and I know it's a little past your guys' prime because most of you guys took the SAT. But you might retake it next year to try to get a better score. By the way, the SAT super scores. You know what that means? There's 4 parts to that test. If you retake the test, you'd have to pay for it. But if you retake the test and you do a little bit better on one of the 4 tests, it just keeps the higher score. So you could retake that and get a super score. Anyways, now f inverse, so that's the domain restriction. F inverse was negative square root of negative x. And again, we have a domain restriction. By the very nature of the function, it has to be less than or equal to, 0. See what happens there? And then lastly, to double check for our symmetry, we're going to plug in y equals x. And I'm going to zoom in on this. I was just kind of, what do you notice? All the stuff that Mr. Adams said would happen, right? Essentially, it crosses the diagonal for sure. Oh, maybe we should do this. For funsies. For funsies, let's do this. Let's make this dotted. And now we'll retake the picture of it. But notice that wherever the two, whichever function crosses, let me get a little bit better picture. They cross the diagonal at the exact same spot. Okay? That's no accident. They're always going to cross the diagonal together. The red line and the blue line will cross the dotted green line in the exact same spot. Okay? Always. So there's that. If it is not the mirror image on the diagonal, because the symmetry goes beyond this little section here, the symmetry continues in this direction. We cut it off in a funny spot just because of the way that I took the screenshot of it, but let's label these things so we know what we're doing. So this was f of x equals negative x squared with the restriction x is less than or equal to 0. This is f inverse of x equals, it's pretty bold, minus the square root of negative x with the domain restriction of x is less than or equal to 0. And then lastly, this right here is my diagonal line, y equals x. And then we should notice that, and let's write this down. I say it a lot, but I think when I say it, some of you guys have made comments like, you don't remember what I say, which is funny to me because you should be listening. But let's write this down in words. F and f inverse will always cross y equals x at the same points. Okay? They're always going to intersect at the same points. So we've got a lot of little clues. This is pretty easy, but it's also easy to make a simple math mistake. It's very easy to forget a negative sign. By the way, if I forget one negative sign in this equation, if I make the wrong decision, if I forget about the domain restriction, which affects the range of the inverse, that's an issue. If I forget to restrict the domain of the actual square root, which is part of the inverse function, that's going to be a different graph. So those are the two little mistakes that somebody might make. Okay? Something to think about.